I'm Dr. B. Today we are going to take a look at how we can do a few calculations on that volumetric analysis. You call it titration in the lab. Do you know that whether you are using the lab or not, you can be able to calculate concentration of either an acid or that of a base, or calculate the volume of acid that you've used or that of a base. Of course, the volume of acid that is used is always calculated and termed your what? Your titer, which is always gathered from the averaging what? Averaging your various readings that you obtain from the endpoint of your titration. Today, I'm going to take us through how we can be able to calculate concentration of acids, even that of bases, from a simple volumetric analysis. Join me. Assuming we are given a question that has these parameters. Let's say we are given concentration of acid, and we said we do not know. Concentration of a base, let's assume that is 0.1 mole per dm cube. We are given the volume of acid. This volume is what you got from, you call your titer value, what you got from your experimentation. Sometimes, if you do not carry out an experiment, you can be given that in your question paper. Let's assume that the volume of acid here is 23.45 centimeter cubic, and then the volume of your base, let's say, is 25 centimeter cubic. Remember that the volume of your base is always known because you are using a pipette to do what? To draw the base. And the pipette could be either 20 cubic centimeter volume, or it could be a 25 centimeter cubic volume pipette. So that is always being known in the lab. Now, assume we are given this, and we are told that the acid and base that are used, because a typical titration is a neutralization reaction. Assuming that the acid that we are being given is H2SO4, which is the hydrochloric acid, and the base that we are using, let's say it's let's use sodium carbonate as the base that we are using. A question can be like this. You can have a question of this nature. Okay? 25 cm cube of 0.1 mole per dm cube of a base, sodium carbonate, was titrated against 23.45 cm cube of an acid, H2SO4, sulfuric acid. What is the concentration of the acid? That's how the question can be. And now we are expected to calculate the concentration of the acid. There is something we must know, that in calculating concentrations, two formulas play an important role there. One is that you can calculate the concentration of an acid in grams per dm cube, or you can calculate it in moles per dm cube. What do we mean by that? If you are calculating in grams per dm cube, then you are going to use MA VA all over MB VB equals to mole ratio. This is the mole ratio of acid and base. This is because in grams per dm cube, you are using mass concentration. You are using mass concentration. But if you are calculating in mole per dm cube, depending on what the question is, then you'll be using CAVA all over CBVB equals to what? Mole ratio. Because here you are using molar concentration. molar concentration. Do you understand it? These are the techniques. If you are calculating concentrations of acid or bases in grams per dmq, then you are using mass concentration. In that case, you are using MAVA MBVB equals mole ratio. But if you are calculating concentration in mole per dmq, then you are considering molar concentrations. And your calculation will be CAVA over CBVB equals to mole ratio. Look at it. We are given the concentration of a base in mole per dmq. What do you think we are going to use? We are not going to use the mass concentration. We are going to use the molar concentration because that is what is given. So we are going to use this formula to do our calculation. That is the molar concentration. But there's something that is important, that is striking, we must note. If we are using the molar concentration, remember that the base is in molar concentration. Therefore, we are not using cubic centimeters. We have to convert them from cubic centimeters to what? dmq. And by doing that, 1 dmq is equivalent to 1,000 centimeter cubic. So to convert them, we would simply divide by 1,000. So we divide this by 1,000, 23.45 by 1,000, and we're going to have about 0.02345 dmq. And then we convert this as well. We're going to have 25 over 1,000, and we'll have 0.025 dmq. Did you see? The conversion is very important because you are working based on mole per dmq, the molar concentration. And when we get that done, the next thing we're going to do is to do what? Substitute this and this into the equation. But there's something very important, something very striking here. And that thing is this. Remember that we are given this acid and this base. And in our equation, there is a mole ratio. So we have to balance the chemical equation in order to arrive at a mole ratio. Now, we are told that a base, sodium carbonate, reacted with sulfuric acid, it will give us sodium sulfate, and it will give us also CO2, and it will give us also water. A neutralization reaction will always give us salt and water at the end of the day. But if you take a look at this question, it's only 1 mole and 1 mole of each of these reacted. So our mole ratio A and B will be 1:1. So let's solve this. In order to solve this, we're going to do our substitutions. Remember that what you have here is the volume of the acid and this is the volume of the base. So with CAVA all over CBVB equals to mole ratio, we now have Ca, which we are looking for, we do not know, multiplied by the Va, which is this 0.02345 dm3, all over what? Cb, which is the concentration 0.1 mole per dm3, multiplied by the Vb, which is what? The 0.025 dm3. This will cancel this, and when we multiply, equals to the mole ratio, which is this. So we do what? We cross multiply. If we cross multiply, we're going to make Ca the subject of the formula, and that will give us 0.1 mole per dm3 multiplied by 0.025, okay, of course multiplied by 1, all over what? This 0.02345, and this will simply give us a value. By the time you multiply 0.1 by this and divide by this, you have 0.1 0.066 moles per dm cube. That means it is a concentration of 0.1 molar of the acid that reacted with the 0.1 molar of the base to give us a neutralization reaction that came up with an endpoint that you saw, giving rise to a salt, sodium sulfate, and what? Water at the end of the day. You can see that this is quite interesting, quite a very simple calculation. Now, what have you achieved? What you achieved is this. Number one, if you are given a calculation in terms of for titration, you must note what you are looking for. Is it the acid or the base concentration? In any case, how do they come? Do they come in mole per dm cube or they came in grams per dm cube? If it came in mole per dm cube, then you are expected to do your calculation using the molar concentration, CaVa over CbVb mole ratio. If it comes in grams per dm cube, you are expected to do your calculation using what? The mass concentration, MaVa over MbVb equals to mole ratio. Secondly, you must note that your volume, if that of your acid is in dm cube, then you must convert your volumes from centimeter cubic to what? dm cube by simply dividing by 1000. 3. Very importantly, you must look for your mole ratio by forming a chemical equation from the acid and base that are being used for the titration. And in that case, you must balance a chemical equation and use their moles to represent your mole ratio. I'm very much sure that you learned something great today, how we can be able to determine concentration of acids from titration method. Do not forget to like, to share, to follow, and to subscribe as well. Until next class, it's bye for now.